this integral belongs to the third case of integration by partial fractions. There are irreducible quadratic factors in the denominator and there are no repetitions. So if you take a look at the given integral from the first line left hand side, the denominator we have x to the fourth plus 5x squared plus 4. First you factor the fourth power, okay, and then after the factor is done, that can be factored into two quadratic factors, x squared plus 1 and x squared plus 4. X squared plus 1 and x squared plus 4, they cannot be factored. That's why I call that irreducible. If you still don't remember this, a squared plus b squared, this cannot be factored. You learned this in elementary algebra. So the plus 1 and the plus 4, they both cannot be factored. So how do you deal with this? For the irreducible quadratic factors, we have to use two letters for each quadratic factor. So the first one, I will use ax plus b, and then for the second one, I will use cx plus d. Cx plus d. And then the next step is you jump into the common denominator. For the first factor, I am looking for another x squared plus 4. So you have ax plus b times x squared plus 4. And then for the cx plus d, you will need an x squared plus 1. You will need x squared plus 1. And then one bad news I have to tell you is you cannot try any convenient values because x squared plus 4 and x squared plus 1, they never equal to 0. It's a parabola shift 4 units up, a parabola shift 1 unit up. They never go across the x-axis. So y will never equal to 0. So the convenient value is not going to work. In this one, you have to go to the hardcore. You have to open everything up and do the crazy algebra and solve the system. All right, let's do it. So x to the third plus 4x plus 3, that is equals to, open this up, you have ax to the third plus 4ax plus bx squared plus 4b plus cx to the third plus cx plus dx squared plus d. Oh, by the way, this, for the crazy algebra parts, if you want to make little mistake, the entire problem is wrong. Okay, so just be careful. The day before you take the test, make sure you get a good sleep. Now, let's group all the powers together. So we have the third power, so the third power, and then we have the second power, and then we have the first power, and then the rest are constants. Okay, let's do the grouping. So x to the third plus 4x plus 3. If you want to save a line, just take the x to the third out. So you can do this. You can just do a plus c, and then take the x to the third out. So that saves one line for you. And then the second power, that will be the red, right? So you can do a b plus d, and then take the x squared out, and then do the first power. The first power would be the purple. That will be 4a plus c, and then you take the power out, and then the last one you have 4b plus d. Okay, so now we equate the coefficient. The coefficient in front of x is 1. There is no square, right? So that will be, there is a 0x squared in there then. So for the first power here, so 1, first power, then that will be this. The second power, that would be the 0 for this. And then the third power, let's pick yellow. Not the third power, the first power, 4, then that will be for this. And then the rest, the 3, will be for the 4b plus d. Okay, let's set up the system. This is called equating the coefficient. Okay, for the system, we have a plus c is equals to 1, and then b plus d, the red, is equals to 0, and then the 4a plus c is equals to 4, and then the last one, the constant 4b plus d, is equals to 3. Oh, this one on the test, good luck with that. You might get a super complicated system. Just good luck with that. I hope that you will get a simple system on the test. Or you can just use the convenient value to, to skip the system. Wow, that looks hard. Okay, how about this? Let's put the c on one side. So let's do c equals to 1 minus a, and then we put the c in here. So this becomes 4a. Let's draw an arrow. That becomes 4a plus 1 minus a equals to 4. Then we have 3a equals to 3. Then a is equals to 1. A is equals to 1. So when a is equals to 1, then c is equals to 0. Just got two values. A and c are solved. What about b and d? So we have b plus d equals to 0, and then 4b plus d equals to 3, right? If we subtract them, 1 minus 4 is equals to negative 3, so we have a negative 3b equals to negative 3, and then b is equals to 3. When b is equals to 3, we have 3 plus d equals to 0, then d is equals to 0. All right, I got a, b, c, and d. Okay, let's plug it into where? Back to the top, the ax plus b, and then we integrate. All right, let's do the plug-in. So we have integral, plug in the ax. So we have a is 1, ax plus b. So we have x, b is 3. So x plus 3 divided by the x squared plus 1, right? X squared plus 1, and then dx, and then the cx plus d. So that will be an integral. C is 0, so that will be a 0x plus d plus a 0. Did I make a mistake? C is equals to 0 and d is... Okay, let me go back and check my work really quick, because on my notes I got d equals to negative 1. What a big mistake right there. Let me fix it. Negative 3b equals to 3 right here. What a big mistake. B is equals to 1, and then 1 plus d is equals to 0, and then d is equals to negative 1. Okay, c is equals to 0, so we have 0x plus d, so that will be minus 1, and then divided by, now I can go back to orange, and then divided by x squared plus 4. Wow, just save the whole problem. Okay, the first one. B equals to 1, One more correction. B is equals to 1. Okay, x plus 1 divided by that, and then plus negative 1 over x squared plus 4. Okay, got it. Just save the whole problem for myself. Okay, the first integral. Let's break this down into 2. So we have x divided by x squared plus 1. That will be a u substitution. And then plus 1 divided by x squared plus 1. That is inverse tangent. And then the last one we can use u substitution. 1 divided by... Oh, I don't think so. The last one is inverse tangent. In case you don't remember the inverse tangent, so let me show you that right now. So the formula is the integral the integral of 1 divided by x squared plus a squared dx, that is equals to 1 over a inverse tangent x over a plus c. So in here, a is equals to 1, and in here, a is equals to 2. And then the first one is just a u substitution right there. So this one, let's avoid using blue. This one, you can let u equals to x squared plus 1, and then du is equals to 2x dx. So the x on top will be cancelled. And then you have, what do you have right there? you have you definitely have a 1/2, and then ln absolute value of, oh, you don't need absolute value, x squared plus 1 is positive. And then the second one, a is equals to 1, then you have 1 over 1, so you only have an inverse tangent x over 1. And then the last one minus inverse tangent of 1 over a, right? So 1 over 2, and then inverse tangent, let's make that look better. So 1/2, and then inverse tangent x divided by 2, and then plus c. That's it. That is the solution to the given integral. So a lot of works. Make sure you check your work. I just checked mine, save the whole problems for myself. Okay, so if you think I gave you the best problem and very clear instruction, let me know in the comment below. Like the video, share the video for me, subscribe to my channel. See you all in the next one. Signing out for now.